last class, I discussed modern physics, that is nuclear physics. Only a few topics is left. First, I will complete that chapter. Okay, today we'll discuss about nuclear reaction. Nuclear reaction and chemical reaction are completely different. In chemical reaction, you have learned in chemistry that electrons are exchanged between the elements and new elements are formed in chemical reaction. But in nuclear reaction, what happens is collision. Collision between two elements happen and new elements are produced because of collision. So let us see, in a nuclear reaction, two nuclei or particles collide to produce two new nuclei or particles. So here is a simple example of nuclear reaction. Helium and nitrogen collides, and oxygen isotope and hydrogen is produced. So energy, this is one important characteristics, that energy is released in all types of nuclear reaction. It may be huge amount of energy in nuclear fusion. Huge amount of energy is released, and in nuclear fission, small amount of energy is released. So there are mainly two types of nuclear reaction. One is nuclear fusion and another is nuclear fission. So energy released by fission of a heavy nucleus into two lighter and always unstable nuclei. Energy is also released by fusion of two light nuclei into a heavier nucleus. So there are mainly two types. Let us see the types of nuclear reaction. In fission, a very heavy nuclei like uranium, it collides with a neutron and it goes to an unstable state. So you can see in the first reaction, uranium goes to excited or unstable state because of collision with neutron. Then from unstable state, it breaks down into two smaller nuclei, that is beryllium and krypton, and three more neutron is produced. This is a type of chain reaction. This type of reaction happens in nuclear weapons like atom bomb or nuclear power plants. This is called chain reaction because you see, first one neutron hits uranium, and because of this collision, three more neutron is produced. So these three neutron will hit another three uranium atom. So 9 more neutron will be produced. Those 9 neutron will hit another 9 uranium. So 27 neutron will produce. So in this way, this is like chain. By each collision, 3 times more neutron is produced. And the reaction happens in a very quick rate. That is why within a very, very short time, huge amount of energy is produced in fission reactions. So fission is a decay process in which unstable nucleus splits into 2 fragments of comparable mass. So you see, this is the unstable nucleus which is produced because of collision with neutron, and from that 2 other nucleus, their mass is nearly close to each other. And there is another example that uranium, it's called. These two are example of nuclear fission reaction. So here basically what happens, large nuclei like uranium or plutonium can split apart during fission. So in fission, only very large nucleus, radioactive nucleus, they goes through fission reaction. And the basic criteria is it produces huge amount of energy within a very short time. Okay, so this is fission and fusion. Here, 2 small nuclei, they collide with each other. This one is deuterium, 2 hydrogen. This is one isotope known as this is tritium, and this is deuterium. Deuterium and tritium, they combine with each other and produces helium isotope. And gamma, and releases energy in the form of gamma ray. Gamma is a type of wave which carries energy. So in a nuclear fusion reaction, 2 or more small light nuclei. So here previously we have seen fission happens to very heavy nuclei and fusion happens to small and light nuclei. They come together or fuse. Fuse means they combine with each other and forms a larger nucleus. Here in these 2 examples, you can see 2 small nuclei, they combine and produces another comparatively larger nucleus. Here also a comparatively larger nucleus is produced because of fusion. So in a nuclear fusion reaction, 2 small light nuclei combine to form one larger, heavier nucleus. So here with the help of a diagram, it is shown that deuterium and tritium, they combine and they combine by colliding with each other. All nuclear reactions, they happen because of collision. And a larger nuclei, helium-4, that is produced, and energy, here a small amount of energy is produced. Okay, so this is the end of the chapter. So here you have to learn what is nuclear reaction, what are the main two types of nuclear reaction, and explanation of nuclear fission and fusion reaction with examples. All these examples of fusion and fission, this nuclear reaction examples you have to learn. Okay, so now I'll go to another chapter. So your last class will be held on 12, right?
Yes, sir.
So up to 12, whatever I will teach, that will be your syllabus. Those topics and first term and midterm. That will be your syllabus for the final exam. In final term, in the last few days, I'll not teach too many topics. So now we'll start another chapter, electricity, electrical charges. From this chapter, mainly I will discuss Coulomb's law and electric force.
এক্সামের আগে হচ্ছে মেসেঞ্জার গ্রুপে একবার সব চ্যাপ্টার গুলো জাস্ট রেখে দিলে বেটার হতো।
All chapters they're given in the Facebook group, isn't it? All chapters slides, those are given in the Facebook group, and in addition I will teach some topics from the book. So this topic, chapter name and page number I am telling all of you, note down. Actually chapter names, yes, I can give the chapter names, no problem, but topics you have to find from the slides, and many maths and many other topics were taught from the book. Those you have to note down. Okay, as you have told, the chapter names I will give. Already there are chapter names, they are given in the Facebook group. In addition to those chapters, I will teach this chapter from the book. I will not give any slide for this chapter. Only two topics I will teach from this chapter, that page number and topic name. These things you have to note down. Do you understand? যে চ্যাপ্টার গুলো পড়ানো হয়েছে, মানে ফেসবুক গ্রুপে যেগুলো দেওয়া আছে সেগুলো তো অবশ্যই পড়তে হবে। And in addition, this chapter I will not provide, because only two topics I will teach from this whole chapter. So I will not provide any slide. You have to study from the book, and these are not at all difficult topics. Okay. So this is chapter 21, electric charge and electric field, and page number 694. Here I will discuss the Coulomb's law. So this is actually very simple and quite similar to the Newton's law of gravitation. In Newton's law of gravitation, we have considered the mass of two particles, and here we'll consider the charge of two particles, and rest other things are same as Newton's law of gravitation. So Coulomb's law says that the electrical attractive force between two charges that is directly proportional to the product of the charges and inversely proportional to the square of the distance between the charges. You see, this is very much similar. The magnitude of electric force between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So if we consider one particle that has charge Q1 and another has charge Q2 and distance between them is r, then according to Coulomb's law, we can write this, where K is a constant. So here modular sign is given because this is an attractive force. The product of two charge may be negative because if one charge is positive and another is negative, then the product will be negative. But since the force is always positive, that is why modulus sign is given. Modulus, you know that if the value is negative, then modulus will make it positive. Modulus of Q1, Q2 means that this value will be always positive. Okay. So this is very much similar. Now the value of K is given here. You have to remember this. This is approximately, you can consider this 9. 9 into 10 to the power 9 Newton meter square per Coulomb square, where Coulomb is the unit of charge. And also we can write the value of K. This is 1 by 4 pi epsilon naught, where epsilon naught is known as the dielectric constant. So this is the value of K, and epsilon naught value is given here. So approximately we can say the value of K, or 1 by 4 pi epsilon naught, equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. So these values, all values you have to remember because we'll do maths using this value. Okay, now let us see one math. Okay, this is example 21.1. All of you note this, the topics. I think previously I also told you that the topics which I am teaching from the book, those page number and example numbers you should note down. Okay, so an alpha particle, the nucleus of a helium atom, its mass m is given. Its charge is double of the charge of an electron. Electron charge, you know, we have learned previously, is also given here. The charge of an electron is 1.6 into 10 to the power minus 19 Coulomb. So double of electron charge is 3.2 into 10 to the power minus 19 coulomb. Now you are asked to compare the magnitude of electrical repulsion of two alpha particles with that of the gravitational attraction between them. So same particles, you have to find the electrical repulsion because here both are positive charges. So same charges always repel and opposite charges they always attract. So you are considering two alpha particle and their charge is same. So there will be electrical repulsive force acting between two alpha particles. So that you have to find, and also you have to find the gravitational attraction between two alpha particles. Then you have to compare. Compare means you have to find the ratio of electrical charge and gravitational attraction. Now the calculation is very easy. We have learned already the Coulomb's law. So according to Coulomb's law, we can write 1 by 4 pi epsilon naught Q into Q. Here same charge. So Q into Q is Q square divided by distance square. And the gravitational force will be G m into m. Since same particle, so their mass will be same. So m into m will be m square divided by r square. So this is the electrical repulsive force and this is the gravitational attractive force. Now if you are asked to compare, so Fe by Fg, this value you have to find, the ratio. So if you divide this, then r square will be cancelled. And finally you will get this equation. 1 by 4 pi epsilon naught G Q square by m square. Now here you will just put the values and you will get the ratio. Q value is given. Value of Q is given here. And mass is also given. 6.64 into 10 to the power minus 27 kilogram. So just from the question we will put the values, and 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9 Newton meter square per coulomb square. And G you know from the chapter gravitation, 6.67 into 10 to the power minus 11 Newton meter square per kilogram square. Now after calculation, the ratio will be 3.1 into 10 to the power 35. So this will be the answer. One thing is, here is no unit. Why is there no unit?
ডিভাইডেড করা হচ্ছে, দ্যাটস ওয়াই ইউনিটও সেম, এর জন্য কাটাকাটি চলে যায়, দ্যাটস ওয়াই এখানে কোনো।
Yes, actually this is the ratio. So both force, all types of forces, their unit is Newton. So Newton by Newton, they will be cancelled. So that is why there is no unit. For ratio, will not get any unit. Any question about this math? Very simple. I think all of you have understood. Next topic is which I will discuss, that is electric dipole. So electric dipole, this is 21.7 and page number 709. So today I will just discuss the definition of dipoles, and next class I will derive some equations for a dipole. So an electric dipole, its definition is very simple. Two equal but opposite charges, when they are separated by a distance, then that is known as an electric dipole. For example, plus Q and minus Q, they are equal but opposite charge. So when they are separated by a distance, that is known as dipole. Here you see plus Q and minus Q, they are separated by a distance t. So this is an electric dipole. So from here we can calculate a lot of things like torque of the dipole. Torque is actually the angular force between the two charge we'll find. Then the dipole moment, then potential energy. This is the equation for torque, which is represented by tau. And we'll also find the potential energy U. So these derivations will take a lot of time to explain. So I will start these derivations in the next class. Rafsan, Afruza,
Present, sir.
Nusrat,
Present, sir.
Sabrina,
Present, sir.
Wad,
Present, sir.
Anamul,
Present, sir.
Tarek present. Ikram,
Present, sir.
Habiba,
Sir, she has informed me in the messenger having some net problem.
okay. Sumaya, Abulala,
Yes, sir.
Jannatul,
Yes, sir.
Shahin,
Present, sir.
Mim,
Present, sir.
Rasif, Mim present.
Yes, sir.
Afruza,
Yes, sir.
Abu Salman,
Present, sir.
Sumaya,
Yes, sir.
Shojibur, Nahidur,
Present, sir.
Alamin, Alamin,